Right. So, hello and welcome everyone. We are live right now. I hope I'm audible to all of you. So, welcome back to this amazing platform of Tutee Learning. So, I hope you have enjoyed watching the previous lecture that I have taken so far on the topic of pair of straight lines, right? So, in the last lecture, we saw that pair of straight line is basically the combined equation of two straight line, right? So, when we multiply both the equations of straight lines, we get a second degree equation, right? So, that particular second degree equation was the general equation of any conics, right? But in the last class, we also saw that when that particular equation or second degree equation represents a pair of straight line, right? So that was what we have seen in the last class. So let us recall that particular concept as we move forward with today's discussion, right? So in the last class we saw that any general 2-degree equation can be written as ax squared plus hxy plus b times of y square plus 2 times of gx plus 2 times of fy plus c equals to 0, right? So that is what we have seen. So this was what we have called as the second degree general equation, which is the equation of pair of straight line, right? So this is a general equation of conics as well, right? So I will write it as second degree or second degree equation, right? So as you can see, the degree of this particular equation is second order, right? So it is a second order degree equation, which is basically the general equation of conics, right? So in the chapter of conics section, we will observe that this is the general equation of any conic. Okay, so any conic section will be represented by this particular equation, right? But which conic section is this particular equation is going to represent, that is will be dependent upon some of the quantities, right, which we'll be trying to see as we proceed with the chapters of the circles, ellipse, hyperbola, parabola and all that, right? So in the previous discussion we have seen that this particular second degree equation is going to represent a pair of straight lines, is going to represent pair of straight lines, right? It is going to represent the pair of straight line equation if and only if, okay? So IFF actually implies that, basically means if and only if, right? So if we recall from the previous class, we have seen that this particular result is exists only when this determinant, which is given as the diagonal elements are a, b, c and the non-diagonal elements are h, g and f, and it is a symmetric matrix, so you can easily produce this particular element. So this should be equal to 0, right? So we have seen in the last class that for this general equation of conics to be a representing the pair of straight line, this particular determinant has to be equal to 0, right? So if and only if you have this determinant coming out to be 0, then only you can achieve that this particular second degree equation is going to represent the equation of a pair of straight line, right? I hope this is clear to all of you, right? So this is what we have seen in our last class. Okay, please let me know if you have any questions. Okay, so do let me know if you have any questions, or else we can proceed with today's discussion, right? So in the previous class we also saw that about the homogeneous form of this second degree equation, right? So in the last class we saw about that when the pair of straight line is having the point of intersection as the origin, so that particular case becomes reduced to a simple homogeneous case of pair of straight line, right? In that particular case, the first order terms of x and y and the constant will be equal to 0, right? So that is what we have seen in the previous lecture. So upon building upon that particular theory, so now if this particular theory holds true, if this particular condition holds true, that basically means that this particular general equation or the second degree equation is going to be a pair of straight line, right? So this is a general case of a pair of straight line, so which is going to have certain point of intersection, okay? So let us call that particular point of intersection by let us say x comma y, right? So we have to also see that how we can find out this particular x coordinate and the y coordinate of the point of intersection, right? X coordinate and the y coordinate of this point of intersection of this general pair of straight line, right? So how am I going to do that? Let us try to see from this, let us try to revisit the concept, right, from here. So in order to find out this point of intersection of this pair of straight line, okay, this point of intersection, this point of intersection of this pair of straight line, of this pair of straight lines. So we have the general equation, that is ax square plus 2 times of x into y plus b times of y square plus 2 times of gx plus 2 times of fy, and then plus c equal to 0, right? So that was the general equation of the conics, right? Now the point of intersection of this particular curve is basically given as, so we'll try to derive this expression. So you can write out this expression, that is given as bg minus hf divided by h square minus ab comma af minus gh divided by h square minus ab. Okay, so this is the expression for the point of intersection of any general pair of straight line equation, right? So how do we get this particular thing, right? It can be solved as well. So what you can do is that you can try to, once this particular determinant condition is verified, then what you can do is that you can try to reduce this particular equation into two linear factors, right? So from there, if you get a two linear factor, that will be the equation of straight line 1 and the equation of straight line 2. So by solving for the point of intersection of straight line 1 and 2, you can easily obtain this point of intersection, right? So but if you want to directly get the point of intersection and you don't want to remember the formula, the easiest way to solve for is basically, first of all, assume this particular expression to be some expression as phi. Okay, so let us call this particular expression as phi. Okay, so what I'm going to do is that I'm going to partially differentiate this phi with respect to x and equal to 0. That would give me one equation, and secondly I will again differentiate this phi with respect to y, and that would give me another two equation, right? So here, by partially differentiating this phi with respect to x and y, I will obtain two equations, right? Now what does this partial differentiation means? So this is basically partial differentiation, right? So you have done ordinary differentiation while you perform differentiation, right? So this is basically, the concept is that whenever you have a function which is variable, which is basically dependent upon two variables, right? In this case, partial differentiation actually means that when you are partially differentiating this particular function with respect to x, that basically means that you are considering y to be constant. So partial differentiation actually means that when you have a function of multiple variables, by keeping the other variables constant, only just differentiate the function with respect to the variable that you are differentiating partially. Okay, so that is basically the concept of partial differentiation. So by doing out or carrying out this partial differentiation, you will obtain two sets of equation, right? You will obtain two sets of equation, and on solving these two sets of equations, okay, you will easily obtain this point of intersection. So you can verify by this particular result. So from here, if you just try to get the two form of equations and equal to 0, and then you solve for the point of intersection, you will easily get this particular result. Okay, so please try to verify this result with by doing this partial differentiation and doing it, right? Okay, so I would leave that particular part up to all of you guys. Okay, and I know that you are pretty much easy to solve this problem, right? It is fairly an easy problem. Okay, so maybe try it out. Okay, try it out. If you're not able to get it, just let me know. I will be able to help you out with explaining the step-by-step derivations, right? So in case you're not able to do it, just let me know, or else we shall proceed with our upcoming discussion. Okay, so by understanding these particular concepts, now we are equipped or ready to basically move forward with discussion about some of the questions. Okay, some of the standard question I will try to put it up so that it will help you out to understand the basic concepts, right? So let us start with the very first problem. So this is the first question what you have to try. Again, a very simple problem. I'm not going to help you out, but you have to do the algebra out by yourself, and it is a very simple problem. So it is said that given this particular second degree equation, when this particular equation is going to represent a pair of straight line, right? So you already know the condition, and based on that condition you have to find out this variable lambda. Okay, so please try to solve this problem. I'm not going to solve it, but I'm directly going to say you the answer, right? So but you have to solve this problem. Okay, so try to solve this problem and let me know whatever answer you're getting. Okay, maybe after that we can build upon some other problems, right? So fairly similar problem. Okay, just try to solve it and then we move on to discuss about some other topics, right? Now, an interesting observation over here is that please try to understand that even if the point of intersection of the line is shifted from origin to any general point like this, but still, what you will observe is that if you are still trying to find out the point of the angle between the two straight lines, let us say this is theta, even if it is intersecting at some point, let us call that point as x comma y, even if it is having some random point or some fixed x comma y point as an intersection point which is not equal to the origin, still you are able to find out this theta by using this particular previous result, right? So that was basically tan inverse of 2 times of square root of h square minus ab divided by mod of a plus b, right? So this was what the result which we have already discussed in case of the homogeneous case, right? So this result remains the same because ultimately you're doing nothing, you're just shifting this particular line to that of the origin, right? So maybe you can do a transformation which you will learn in the upcoming discussion, which is called as the homogenization of the any general curve, right? So we will see that you can also use this particular concept to just transform this particular pair of straight line to any random or any point of intersection to the origin as a point of intersection, right? So maybe we will learn about it, but just to let you know that this particular concept still holds true. Okay, so please try to solve this problem. Please try to solve this problem and then we go for the other formulations. Okay, so just solve this problem and let me know whatever answer you're getting. Just solve this problem. Okay, so just try to solve this problem. Just let me know the answer you're getting. What is the answer you're getting? It's a fairly straightforward problem. So what you have to do is that you have to just equate the determinant to be 0, right? So here the coefficients a, b, c are very straightforward. So which I can write it down like this, and it will be 7, 3 and 8, 7, 3 and 8, and this determinant should go to 0, right? So if you solve for this particular determinant to be 0, you will obtain the value of lambda, to turn out to be just come out as 8. Okay, so maybe you can try out, you will see the lambda should turn out to be 8. Okay, so please try to solve this problem, you will see that answer of this lambda value should come out to be 8. Okay, I hope this is clear. I hope this question is clear to all of you. I hope this result is clear, right? So now let us move forward in solving some other important problems, right? So it is very important to understand and realize the importance of these kinds of problems, because in generally when people are given general equation of any conics, they underestimate and directly say that it is a equation of pair of straight line, right? But please note that it is a general equation of conics, which is basically going to represent pair of straight line if and only if this particular condition is going to hold true, right? Without having this knowledge of this condition, you cannot directly say that it is a pair of straight line, right? All right, so let us move towards solving some other problems which is regarding the angle transformation. Okay, so maybe this problem is going to help you out in understanding on how to get the modified equation of the pair of straight line in a different form, right? So it is basically said that if a pair of straight line is just rotated by origin with respect to the origin at an angle of 90-degree, right? So what will be the new equation of the pair of straight line that you are going to obtain? So that is what you have to solve for in this question. Okay, so please try to solve this problem and let me know whatever answer you're getting. Okay, please try to solve this problem and let me know the answer. Please try to solve this problem. Please solve this problem. Okay, try solving this problem and do let me know the answer you are getting. Alright, so I hope you have read through the problem. So let us quickly see how we will be able to solve this problem, right? Again, the idea is very simple. You have to just do the rotation of the pair of straight lines. So again, a concept of angle transformation, right? But what we're going to observe is that this problem can be easily done. So let us read the problem. So it is said that if the pair of straight line, which is given by this particular form, is rotated about the origin through an angle 90 degree, right? Now it is not mentioned about which orientation it is rotated, right? Anti-clockwise direction or clockwise direction, right? So we have to find out the equation in the new position, right? So we have to find out the equation of the pair of straight line in its new position, right? So how am I going to solve this problem, right? So let us try to analyze this problem. Now we have this simple case of an homogeneous pair of straight lines, so which is basically two straight line passing through the origin, right? So this particular equation is basically the homogeneous equation of straight line, which basically means that straight lines, two straight lines. One is basically I can assume as y is equal to m1x, and another line I can assume is basically y is equal to m2x, right? So these are the two equations of the straight line passing through the origin, right? So these are the two equations of straight line passing through the origin. Now we have already seen this particular relation holding between the slopes, that is basically m1 plus m2 is equal to minus h upon b, and my m1 m2 is going to be equal to just a upon b, right? So building upon this particular thing, I can obtain the relation between the slope of the two lines, right? Now when the both the pair of straight line is basically rotated by 90-degree angle, what I will observe is that, let us try to consider this particular problem by a form of schematic diagram. So if I have, let us say this is my two form of straight lines which is basically passing the origin, and now let us call this particular slope as m1 and this particular slope as m2. What has happened now is that this particular line is now transformed to perpendicular angle, and let us say m dash, and similarly this particular is also rotated perpendicular, let us call as m2 dash, right? So this particular angle and this particular angle is basically 90-degree, right? So what I can observe is that m1 dash into m1 should be equal to minus of 1, and m2 dash into m2 should also be equal to minus of 1, right? So this is the two results that will be hold true, right? Because these lines are perpendicular with respect to perpendicular lines, right? So perpendicular lines with respect to this particular lines, right? So when the pair of straight lines is rotated, it basically means in the rotated form, the individual lines are perpendicular with respect to its corresponding perpendicular lines, right? So that is what I'm trying to explain over here. So from using this particular concept, what you can try to find it is that, so this then I can modify my equation to find out m dash. So m1 dash plus m2 dash will now be equals to just minus of m1 minus 1 upon m1 plus minus 1 upon m2, right? This will be the modified sum, and therefore the sum of m1 dash plus m2 dash will turn out to be minus of m1 plus m2 divided by m1 m2, right? This is going to be turn out the sum as, right? Now over here, now this m1 plus m2 we have already known, that is basically minus of 2h upon b, and this m1 into m2 is basically a upon b. So this b and b get cancelled out, and ultimately we will get the sum of this m1 dash plus m2 dash is going to turn out to be this will become plus, because minus of minus will plus. So it will turn out to be 2 times of h upon a. So this particular sum is going to be 2 times of h upon a, and similarly the product of m1 dash into m2 dash is going to be just 1 upon m1 m2, and that will turn out to be b upon a, right? So from this also I can formulate the given new equation of the line, that is going to be y square into m1 m2, right? Y square into m1 m2. So that is going to be, oh sorry, y square plus m1 into x square, right? m1 dash into m2 dash x square plus, sorry, it should be minus m1 dash plus m2 dash, this plus of it, and this should be multiplied by x by x is equal to 0, right? So this will be the modified equation, this will be the new equation in the rotated form, right? And I just substitute these values back over here, and I will obtain, this will turn out to be just a y square minus 2hxy and plus bx square, right? So whenever you will see that my modified equation of pair of straight line is just made, in place of a it is basically b, and in place of B, it is just A, and also the sign of this H become negative, that basically means that the line is rotated by 90 degree, right? So whenever I will have this particular form of line and I see this particular form of line, they are basically having an angle of 90 degree, right? So that is basically obtained by rotating it by 90 degree angle. I hope this is clear to all of you. Okay, I hope this result is clear to all of you. Okay, so let us now move forward to understand the another general concept, that is basically the combined equation of pair of straight line joining the origin and the point of intersection of a curve and a line. So this particular concept is also known as the homogenization. So what is this concept? So let us say this is my coordinate axis. Let us say this is my coordinate axis, x axis and y axis, and let us say I have any general curve like this, right? And if I take up 2 points, let us say point A and point B, and I have a straight line passing through this point A and point B. This straight line is passing through this point and point B. Let us call this equation of straight line is basically sum mx plus c, right? Y is equal to mx plus c, right? Y is equal to mx plus c. So it is basically intersecting this particular curve. Let us say this curve is C, some curve equation which is obtained by capital C. So I will obtain 2 points A and B, right? Now if I join these 2 points A and B with the origin, I will obtain straight lines, right? One pair of straight line, right? Now this pair of straight line combined equation can be modified and written as, so let us say this particular line equation, maybe I am going to write this line equation in terms of another variable. Let us say Lx plus my plus n is equal to 0, right? So from this result, what I can modify, I can write this particular expression is equals to 1, right? So it's a very interesting expression. What I'm writing is that, so I'm taking this n on this right hand side and then I'm dividing by minus of n to obtain 1, right? So it's a very interesting expression. Now this particular value is equals to 1, right? Now I can have this general equation of this curve equation basically will be given as ax squared plus 2 times of xy plus by squared plus 2 times of gx plus 2 times of fy plus c is equal to 0, right? So what I'm going to do is that I'm going to modify this particular equation such that it becomes a second order equation where I have no first order term, right? So in order to do that, what I'm going to do is that if I look into this particular terms of x and y, I see a 1 can be multiplied over here, right? So I can assume this is 1 multiplied, and similarly the constant term that I have over here, this constant term can be imagined as c into 1 square, right? Now what I'm going to do is that I'm just going to put it back this value of 1 in this following equation, and this will give me this equation to be modified as something as ax square plus 2 capital Xy plus by square, which is equals to 0, right? So I will get this as my modified equation of the curve, right? And now this modified equation of the curve is nothing but it is the pair of straight line equation. Okay, so this particular pair of straight line, that is my, let us call this point as origin O. So this is my combined equation of OA and OB. Okay, so this is my combined equation of pair of OA and OB. Okay, so the pair of the straight line equation is basically given by this particular expression. Okay, so by doing this particular modification or by doing this transformation kind of thing, we are easily able to get to the equation of that particular curve, and this particular process is called as homogeneous. So any curve can be homogenized with respect to a straight line and can be made a homogeneous curve, right? So that's why it is called as homogenization. Okay, I hope this particular concept is clear to all of you, right? So this is a very interesting concept that we'll be using in our general day-to-day discussion. Okay, maybe in the upcoming topics of conic section, we will try to use this particular concept in order to homogenize the curve and try to find out the equation of the two straight lines in order to find out some of the geometrical parameters, right? So with question, we will try to see this particular topic in detail, right? So I hope this particular discussion is clear to all of you, right? So with this discussion, we are ending this particular chapter on our straight lines, right? So this straight line is now officially ended. Okay, so I hope this particular discussion helped you up in understanding the entire concept of the entire chapter. Now on basis of this particular concepts and chapter, what you have understood in this particular lecture, you can use this particular lecture as your understanding basic lectures to build upon more theories. Okay, so maybe in the upcoming topics of circles and hyperbola, ellipse, and those particular results, you will see that we will be definitely using this particular concept of straight lines, right? So this straight line is a basic concept. Basics of coordinate geometry is definitely going to be used everywhere in the conic section discussion. Okay, so with this particular word, I would like to conclude the session over here, and thanks for joining us on this platform. And if you're in this particular platform, please share this uh, please subscribe to the channel and also hit the bell icon, and also try to share this particular videos with your friends and your relatives or maybe your juniors, right? Because we are trying on our motto to spread this free education all over the YouTube, right? So maybe through this particular platform of YouTube, we are trying to reach out to the entire general mass who is basically interested to study mathematics. It is not only for preparing for JEE Mains and Advanced examination, it is also for preparing for any competitive examination. Now I know that in order to get access to good lectures, you have to pay a lot of amount of money, right, in these days. But however, by using this particular YouTube, you can definitely get access to this particular content just free of cost, right? So you just have to have an internet connection and turn into your YouTube to watch this particular lecture. Okay, so with this, please support us on this our journey and this motto. So I hope to see you soon in our upcoming discussion. So tomorrow we are going to start with our new chapter, that is going to be circles. Okay, so with this, I thank all of you for this for joining us live, and we hope to see you soon in our upcoming discussion, and I wish you all the best. Thank you.